Alright, so in our last video, we were looking at algebraic ways that we can evaluate limits. And so I want to start talking about vertical and horizontal asymptotes because they are very much related to this idea of limits, which is that as for a function f of x, as x gets closer to some number, then does your function get closer to a certain y value. And so that is very much what vertical and horizontal asymptotes are about. So let's talk about horizontal asymptotes first. Okay. So essentially, horizontal asymptotes are values, y values, such that, well, maybe I should just draw a picture first to show you. So let's do a quick picture. So let's say we have a horizontal asymptote. So go. At some value y equals a. Horizontal asymptotes, all right, mean that as my function goes to infinity or negative infinity, so as my function goes to positive or negative infinity, then, as x, f of x, as x approaches positive or negative infinity, so as you can see here, right, x is approaching positive infinity, f of x is approaching a value. So as we get bigger and bigger and bigger, as our x values get bigger and bigger, our y values are approaching some value. So how do we evaluate horizontal asymptotes? Oh, I want to make a quick note before we go into that. If our function can indeed cross, okay, a horizontal asymptote, as you can see here, I'm intersecting at several points, as long as this behavior is what ends up happening. As x approaches plus or minus infinity, f of x approaches some value. So how do we evaluate horizontal asymptotes? So there are three cases where you're going to have to evaluate horizontal asymptotes. So the first one is if we have some function, a rational function, so some rational function, where the degree of the numerator and the denominator are the same. So a degree. So what is the degree of a function? Well, the degree of the function is the degree of its highest exponent. Okay, so let's just do an example. Let's do x squared plus 3x minus 6 over 2x squared minus 7. Okay, so this is a rational function. And as you can see, the highest exponent in the numerator is a 2. The highest exponent in the denominator is also 2. So they have the same degree. What do we do in a case such as this? So I want to explain to you how we get to the horizontal asymptote of this function. So first of all, I'm going to factor out that highest degree term, the x squared. So I'm going to factor out my x squared. So over here, I'm left with a 1. Over here, if I factor out an x squared, I only have an x. So I'm going to have to divide by x. And then lastly here, I don't have an x squared, so I have to divide by x squared. So if this is confusing, I just want to show you real quick. Okay, if you factor anything else, so let's say actually let's say I'm factoring out a 2. And let's see if I factor out a 2, I'm left with a 4 because when I multiply 2 and 4, I get 8. 2 and 4 are factors of it. So when I factor x squared here, okay, So if I factor out x squared from 3x, if I multiply, if I factor out x squared from 3x, I am left with 3 over x, because if I multiply this back, I get 3x squared over x, which is equal to 3x, which is what my original term was. So that's how I factored out. And then I'm going to do the same thing on the bottom. I'm going to factor out an x squared. I'm left with a 2 minus 7 over x squared. So as you can see, I have an x squared in the numerator, an x squared in the denominator. They cancel out. I am now left with 1 plus 3 over x minus 6 over x squared over 2 minus 7 over x squared. Now, horizontal asymptotes look at x approaching positive and negative infinity. That's the behavior we're looking for as x gets really, really, really big or really, really small. So let's plug in positive infinity and see what happens. So I plug in my infinity where my x's are. Okay, so as you can see, this term, 3 over infinity, approaches 0. Okay, so why is that? Well, if I have $3 and I divide it amongst infinite people, each person will get a smaller and smaller amount. And we're going to approach 0. Okay, so if I take $3 and I try to divide it between so many people, each person is basically going to get 0. So if I take 3 and I divide by infinity, it approaches 0. Same thing applies to this. $6 divided amongst infinite people approaches 0. $7 divided by infinite amount of people is also 0. So I'm left with 1 over 2. And that is my horizontal asymptote, y equals 1 over 2. So if you notice our original function, I'm just going to write it back down here, x squared plus 3x minus 6 divided by 2x squared minus 7. If you look at the exponents of the highest degree terms, you can see that the coefficients, okay, of the highest degree terms is equal to 1 over 2, which just happens to be our horizontal asymptote. So actually, we showed that whenever we have the same degree of our numerator and our denominator, we can factor those out and cancel all other terms except for the coefficients of the leading term. So whenever you have, when your numerator has the same degree as your denominator, the horizontal asymptote is equal to the coefficients of the leading term. Okay, and we didn't have to go through all this. I could have just told you that. We didn't have to go through this factoring and canceling, but I wanted you to see why this happens. Why we can just take the coefficients of the leading terms, and that's our horizontal asymptote. It's because all the other terms cancel out when we factor our leading term, x squared. Okay? So that's the first case, when we have the same degree numerator and same degree denominator. We want to know what happens with, let's say if our denominator has a higher degree. So let's say we have something like 5x minus 2 all over 3x cubed plus 7. Okay? So as you can see, in this case, our denominator has a higher exponent. So denominator has a higher degree than the numerator. Okay, so what do we do in that case? Well, let's just use logic and think about it. Again, horizontal asymptotes happen when x approaches plus or minus infinity. As x approaches infinity, then, the denominator grows much more quickly because it has a higher exponent. So it just, anytime you put anything into x, it just gets cubed, which becomes a very, very large number. Whereas this is linear up here, so it doesn't grow as quickly. So since our denominator grows more quickly, it means that our denominator approaches infinity more quickly. Anytime you are dividing by infinity, you approach 0. So, approach 0. So, whenever you have a denominator that has a higher degree than the numerator, your horizontal asymptote is equal to 0. So when your denominator has a higher degree than the numerator, the function's horizontal asymptote is y equals 0. Okay, so again, I could have just told you that whenever you have a higher degree in the denominator, it's automatically 0. But again, I want you to understand why. If we have a higher degree in the denominator, it goes to infinity much more quickly, meaning I'm dividing by infinity, so I approach 0. Okay, so in the next video, we'll talk about the third case for horizontal asymptotes, and we'll also talk about vertical asymptotes. In the meantime, you can do some practice and find the horizontal asymptotes. So find horizontal asymptotes of the following functions. And okay, so you can try this on your own and try to find the horizontal asymptotes of these two problems.